Welcome back, 6th grade geologists. Well, in this video we're going to talk about weathering and erosion, and you're probably wondering why on earth is she dedicating an entire video to weathering and erosion. Well, actually, weathering and erosion are similar, but they're different, and it's important that you understand the difference between the two of them. So that's why we're going to have an entire video over it, and I have a YouTube video I'm going to show you. So I'm just going to read what this says here about weathering and erosion. Weathering and erosion. A rock on Earth's surface is consistently broken up by weathering, the effects of freezing and thawing, plant roots, acid, and other forces on rock. After the rock is broken up, the fragments are carried away as a result of erosion, the process by which running water, wind, or ice carry away bits of broken up rock. Okay, there's not a lot of information in there, but it's important stuff, so let's put it in our notes real quick. I'm actually going to make an entire new section for this one. Actually, I'm going to title it Making a Sedimentary Rock. And then I'm going to go ahead and talk about each one. So let's talk about weathering. And the book said that weathering is the effects of freezing and thawing plant roots, acid, and other forces on rocks. The effects of freezing and thawing plant roots, acid, and other forces on a rock. Make sure I got that right. Yep. Other forces on a rock. So what weathering does is it breaks down the rock. And then you have erosion, which happens afterwards. And erosion, according to our book, is the process by which running water, wind, or ice carry away bits of broken up rock. So it is a process by which water, wind, and I don't remember the rest of it. Water, wind, running water, wind, or ice. Running water, wind, or ice carry away bits of broken up rock. Broken up rock. So that's what erosion is, weathering and erosion. So to kind of further this point a little bit, I have a video. It's a Crash Course Kids video that we're going to watch. So here we go.
Amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes. And no, sure, this is what Earth looks like from space, but even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere?
So what that means, the hydrosphere is the water on Earth, and the geosphere is the land on Earth, is what she's talking about here.
To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are two types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones.
So we're going to talk about mechanical weathering and chemical weathering here in a little bit. You'll also hear mechanical weathering called physical weathering. Just a little tidbit.
Frost, ice, the roots of plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah, but not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up. Let's take a trip to the beach to see what part the hydrosphere plays in weathering and erosion. This is a picture taken from space of the coastline of Massachusetts in the northeastern United States. It's part of a landform called Cape Cod, and the picture shows what the beaches and islands around it looked like in 1984. Now look at this photo from 2014. What's different? There are actually more islands in 2014 than there were before. Back in 1984, that long strip of land was North Beach. Now, that strip of land has been chopped up into separate islands. The top part is North Beach, the middle area broke off into North Beach Island, and the bottom part is now called South Beach. So, how did that happen? Well, moving water is a major cause of erosion, and there's a lot of moving water in the Atlantic Ocean. The intense energy of ocean waves crashing on shore causes pieces of the rocky, sandy coastline to break into smaller pieces or to weather over time. Then, natural forces like major storms and rising sea levels then move or erode these smaller pieces. Day to day, you might not notice any dramatic changes, but over the course of 30 years, well, as these pictures show, coastlines can change a lot. So, what can we take away from this? Well, we saw that water can weather and erode Earth's landforms, and that's just one example. There are so many others, like floods weathering valleys or glaciers eroding mountains. Let me break it down for you this way. See what I did there? The hydrosphere shapes and sometimes moves the geosphere. One last joke before I sign off. What did the geosphere say to the hydrosphere? You crack me up.
Okay. So as cheesy as that was, it did include a lot of really good information that I want to make sure we add to our notes a little bit. So we're going to add the two types of weathering in here. So the first one she talked about was mechanical weathering, and you can also hear that referred weathering. You can also hear it referred to as physical weathering. But the video said that mechanical weathering almost there. There we go. Breaks big rocks, process of breaking big rocks into little rocks. Process of breaking big rocks into, little rocks. And then it gave the example of things that could help it, like frost. Frost, ice, plant roots, running water, and sun heat. Frost, ice, running water, plant roots, and heat. And then it also talked about chemical weathering. And it involves changes that some substances can cause on the surface of a rock. So we'll put changes that some substances can cause on the surface of a rock. And then that one gave examples like carbon dioxide, oxygen, and what's the other one? Acid. So you're going to do a study jams video here in a little bit that's going to explain these a little bit more to you, so I'm not going to go in too far of depth. But mechanical weathering or physical weathering just breaks them apart. Chemical weathering changes the rocks. Think, for example, of rust. Iron is considered a mineral, right? But iron is changed by chemical weathering, and it can rust. Same sort of idea. Well, that's the end of that video. So I'm going to let you go ahead and get started on the next stuff, and I'll see you later. Good luck!